This is Calculation Domination book from mathcelebrity.com. Introduction. Did you know you're only one mindset shift away from getting the grades you want and the life you want? That's right, and I'll show you how, but first, let me tell you a story. Years back, I'm tutoring math students on the side, and I saw something interesting. No matter what background they had or where they lived or what class they had, they all struggled with the same few issues: math anxiety, confidence, shame, not knowing how to start a problem, not knowing how to finish a problem. It was around this time I started Math Celebrity, the fastest math tutor on the planet. And since this time, I've met some interesting people, including some of the top test takers and math students on the planet. As I talked to them and watched them work through problems, an interesting pattern emerged. They all used mental models. It wasn't that they were born special or had connections in math. They thought differently. And from my research, I discovered they used things called mental models. If you've not heard of mental models before, it's okay. I didn't hear about them either. But once I discovered them, it felt like discovering mental gold. After reading books and watching videos online, I discovered some of the best thinkers in the world swear by them. Elon Musk used them for the building of his rockets in SpaceX, and Warren Buffett used them with his partner Charlie Munger to make billions of dollars. This book is all about mental models. While there are hundreds of them, we'll focus on the key models for math class and tests. These models help sharpen your thinking and power up your ability to recognize patterns in math. If the brain is a toolbox, you are only as good as your tools, and mental models give you the sharpest mental tools to improve math scores and melt math anxiety. I grouped the mental models in this book by the initial discipline they were discovered in. But make no mistake, all of these models have use in math class. And the examples I give of using the models all relate to math. So if you are not a scientist, for example, you should still read the science chapter, because many of the mental models in science apply for things like decision-making and math class. They can help improve your life and reduce stress and bad decisions. My favorite quote about mental models, and one that I hope you take away as you go through your math career as a student or help guide your child as a parent, is this: mental models are a conduit to a superhuman mind. Tom Chanter. These mental models help you reach the top 5% of a chosen field. And that's where you want to be, because that's where all the money and the glory and the opportunity is. When you use them in math and life, they give you a powerful advantage on your quest for success. Use them for math, career, and life, and they will steer you in the right direction of success. Picture your original thinking and thoughts as murky water. Mental models act like a filter to remove the sludge and confusion. And after you run your thinking through these mental models, out comes perfectly clear thinking. Chapter 2. Science. An object at rest stays at rest, and an object in motion stays in motion, with the same speed and in the same direction, unless acted upon by an unbalanced force. Newton's first law of motion. Imagine you're a rock in the sand on a beach. Without wind, waves, or people, you'd never move. You'd lay there, basking in the sun. I use this example because it represents humans. In science, you'll find a mental model called inertia. Objects at rest tend to stay at rest, and without an external force to jolt the object out of inertia, it will stay that way forever. For math class, students get inertia. It's human nature to be lazy and procrastinate for certain things. When inertia for math sets in, the student may lounge around the house or find activities to avoid math homework. The challenge becomes, how do we fight mathematical inertia? And the answer can be rewards, punishments, or removal of barriers to start homework. The top 5% of math students all put in systems to fight inertia. Suppose we have a child in algebra who has nightly homework. Maybe they don't mind doing homework, but they need reminders or nudges to do it. We also know they love technology and spend time on their phone. The first answer for this situation is, how do we use the phone to help our students start homework? And the answer could be an app or daily calendar reminder to nudge them to do homework. The calendar app creates another mental model called a forcing function. A forcing function is any task, activity, or event that forces one to take action and produce a result. But when I say forcing, I don't mean physical force. I mean something which sets a trigger to do the homework. Apps like Stay Focused let you choose certain apps to be blocked with conditions to unlock. This is to stop you from impulsively using your phone. For example, it has a strict mode that prevents you from uninstalling the app altogether. This means you have to control your impulse and not use your phone at all. To unlock your app, you must meet certain conditions. So imagine a student who impulsively uses social media gets their phone locked. And it can only be unlocked when math homework gets finished. Forcing functions create a nice incentive to break out of inertia. Another way to combat inertia involves the Pomodoro Technique. The Pomodoro Technique is a time management system that encourages people to work with the time they have rather than against it. Using this method, you break your workday into 25-minute chunks separated by 5-minute breaks. After about 4 Pomodoro sessions, you take a longer break of about 15 to 20 minutes. For each Pomodoro session, you get an egg timer or a timer on your phone and set it to 25 minutes. During this time, you can't get up from the chair. You could stare off into space or twiddle your thumbs, but you cannot get up from the chair or have your phone. Now what happens is, after a few minutes, the student will get bored and by default start to do their homework. The Pomodoro Technique takes advantage of another mental model called Parkinson's Law. Parkinson's Law states work expands to fill the time available. By introducing a shorter time constraint, 2 things happen. First, shorter work bursts mean more attention span. And second, when the student realizes they can't do anything else sitting at the desk, they figure they might as well do some homework. 25 minutes isn't long, so they realize the time will pass. But they also realize that time is limited. Chapter 2. Problem Solving. After watching Elon Musk describe his thinking process, I knew the world struck gold. And I instantly saw ways to use this thinking for math students. The first time I saw Elon Musk mention mental models was on an interview when asked about the parts needed for a rocket. He talked about reasoning from first principles. Quote, "I tend to approach things from a physics framework," Musk said in an interview. "Physics teaches you to reason from first principles rather than by analogy." So I said, "Okay, let's look at the first principles. What is a rocket made of? Aerospace-grade aluminum alloys plus some titanium, copper, and carbon fiber." Then I asked, what is the value of those materials on the commodity market? It turned out that the materials cost of a rocket was around 2% of the typical price. End quote. Instead of buying a finished rocket for tens of millions of dollars, Musk decided to purchase the raw materials for cheap and build the rockets himself to create SpaceX. I love the first principles mental model because it forces you to ask yourself a question. How do I know what I think is true is true? To reason from first principles, we ask ourselves the following questions for any decision. Why do I think this? What exactly do I think? How do I know this is true? What if I thought the opposite? How can I back this up? What are the sources? What might other smarter people think? How do I know I am correct? What if I am wrong? What are the consequences if I am? Why did I think that? Was I correct? What conclusions can I draw from the reasoning process? First principles is one of my favorite mental models and one that I see the best math students and test takers in the world use. Having Elon Musk go on record to praise the power of it is one of the reasons I wrote this book. For math class, use first principles to challenge pre-existing beliefs about yourself. The biggest pre-existing belief which damages students goes like this. I am not built for math. I am not good at math. Math is too hard. The pre-existing belief by many is that great math students and test takers are born. This is untrue. Some of the best test takers and math students I know iterate themselves to greatness. They start practice exams with a D score. Then they get to a C, then to a B, and eventually to an A. If you take nothing else away from this book, take this. Stop studying, start iterating. You want to constantly make changes. Are you sure you're bad at algebra, or is your attitude bad? Is your environment for studying bad? Is your self-esteem bad? Because if the answer to any one of those answers is true, you can change the cause, which changes the effect. Are you sure you're bad at math, or have you just not iterated enough? The best math students treat math like a professional video gamer. They make constant tweaks and small adjustments until they get the result they want. Iteration means you are a constant work in progress for the better. If you iterate enough, many of your pre-existing beliefs will evaporate, and in their place, a new vision of your future will emerge. As a parent of a student, success starts with examining pre-existing beliefs about math. As a student, it starts with examining your beliefs about yourself. Here is an example of first principles in action from a student I worked with. Student, I am not good at algebra. Me, why do you say that? All algebra problems? Student, not all algebra, I guess. It's mostly factoring. Now notice, by using first principles, we've narrowed down the problem in just a few seconds from all algebra to factoring. Now watch as we drill down even more. Me, so you get all factoring problems wrong? Student, well, I get certain types wrong. When the students showed me the incorrect answers, they all had one thing in common: exponents. So now we've narrowed down the issue from all algebra problems to factoring with exponents. In 2 moves using first principles, we have slashed the problem down to a bite-sized issue. By giving the student 2 rules about factoring using addition and multiplication of exponents, the problem was fixed in 1 homework session, and homework issues were resolved. Using first principles, we want to drill down to the smallest truth we know to be true. No assumptions or secondhand tales are allowed. When you do this, you cut to the root of the problem. Building on first principles, we move to the next mental model called second-order effects. Put simply, second-order effects mean what happens next. And this includes unintended consequences. What are the immediate effects after a decision has been made? Suppose we have a student who gets groggy after eating. Besides changing diet, suppose we schedule homework before eating. Because if the second-order effects of eating mean grogginess, this affects homework performance. Here is another example. I once knew a student who was getting C's in pre-algebra, and they transferred mid-year to another school district. They used the same textbook, same class, and same grade level. The only thing that changed was the teacher. And guess what? The new teacher inspired the student, helping her get an A in pre-algebra instead of a C. How could this be? Second-order effects. A new teacher means a new approach and a new environment. What happens next? Stories like these contradict the narrative on math students are born, not made. So as a parent, ask yourself, what are the second-order effects of the decision made during and before homework? What happens next with the decisions you make on school, tutors, and educational path? One of my favorite books is called Obvious Atoms. The book features a guy named Adams who has a knack for solving problems nobody else can figure out. And the hook of the book is all his solutions after the fact seem totally obvious. His colleagues ask, why didn't we think of that? The book offers a 5-step checklist for detecting the obvious. 1. The problem will be solved when simple. The solution, when found, will be obvious. 2. Does it check with human nature? Can you explain it to the everyman? 3. Put it on paper. Does the summary fit in 2 to 3 paragraphs? 4. Does it explode in people's minds? Does their face light up or does it produce an aha moment? And 5. Is the time ripe? I had a homework tutoring session with a student once who was bright and had creative ways of solving problems, but their grade didn't reflect it. Upon further investigation, we found the questions she got wrong came from not checking her work, specifically making errors on double negatives. She was so used to subtracting off the opposite for equations that when she had negative numbers, she'd subtract instead of add. So once we built a checklist for her to do the opposite of the original number in the equation, the problems vanished. Example, 2x plus 9 equals 31. She nailed these problems by subtracting 9. But for problems like 2x minus 9 equals 31, she'd subtract 9 as it was drilled into her head from the positive number problems. Once I gave her the checklist of do the opposite of the farthest number on the left side's sign operation, she never struggled again. Now here's a 5-step creative approach to the obvious. 1. What is the simplest way of doing it? 2. Suppose the whole thing were to be completely reversed. 3. Can a vote be taken on it or the public's help actively enlisted? 4. What opportunity is being overlooked because no one has bothered to develop it? And 5. What are the special needs of the situation? That is the obvious detection mental model. Now here's another mental model I love to use when drilling down from excuses to truth, and we call it the 5 whys. Asking yourself 5 whys about a given subject is a great way to push yourself to find the truth and achieve rationality. Example, a student tells a parent they're not good at math. The parent says, why do you say that? The student says, well, I always get C's. The parent says, why do you always get C's? The student says, well, I don't understand the material. And the parent replies, why don't you understand the material? The student says, I do good on homework, but forget formulas on quizzes. And the parent says, why do you do good on homework, but forget formulas on quizzes? The student replies, I get nervous during tests and my brain freezes. And the parent says, why do you get nervous during tests? And the student replies, because I have anxiety the night before and I can't sleep. Boom. We've located the root of the problem. A student who does well on homework but not quizzes usually has a physical or mental issue behind the problem. With students who stress over quizzes the night before, we have a few solutions. First, meditating or relaxing rituals before bed. Second, how can we reframe quizzes as not a big deal like homework? If the student feels no pressure during homework, how do we recreate this physiology in the student when they have quizzes? Third, we can reframe quizzes as homework with a time limit. The anchored association to homework, which they do great at, helps them to change their point of view. Finding this is all possible thanks to the 5 whys. Having run Math Celebrity since 2007 and getting millions of visitors to my site, I get asked questions about math and education. And if there's one question I get more than anything from parents and students, it's this: when will I ever use algebra in the real world? You could substitute algebra for just about any subject, but algebra comes up the most. And my answer is below. I am a big fan of origin stories with superheroes. How did they get started? How did they transform into what they are today? I do the same with certain words. I love to find out the etymology of words. When I dug into the etymology of the word algebra, it comes from an old Arabic word, al-jabr, and this means the reunion of broken parts, like the final solution of a puzzle put back together. Now, why is this significant? Well, if you look at your life from a high level, you go to school, you get a job, you start new relationships, and you learn new things. What do all those events have in common? Problem solving. No matter where you go, who you meet, and what you do, you solve problems every day. So even if you never go into a math-based career after school or use math in your job, you do use problem solving. Algebra and other math topics power up your problem-solving muscle. And if you look at problem solving as a weapon, then math classes like algebra are your razor sharpener. Whether it's crazy theorems, multi-line proofs, or complicated equations, think of math class as your obstacle course to the real world of problem solving. Because conquering math helps you get ready for the real world of problem solving. Problem solving has universal applications. The same tools and principles you use in math class will be used in other areas of your life. Math class gives you the chance to build and sharpen these skills for when you go out to the real world and get a job and start relationships. So the next time you struggle with math and ask yourself when you'll ever use this in the real world, imagine your future 5, 10, 15 years from now. You'll still be solving problems, but the question becomes, how good will you be at solving them? When you think about this, you now know your real mission in math. And as I said, I love getting to the root of things, especially words. The etymology of the word teacher comes from Germanic origin. It means to show or point out. Pointing out means drawing attention to. Traditional teaching throws up a concept on the board and then says, "We're having a test in 3 days on this." By doing this, the teacher just scratches the surface of the concept. They talk at you, not to you. They don't speak to the deeper structure of things, and it's in the deep structure of things where the learning and epiphanies happen. And while we're on the subject of etymology and deep structure, the word student comes from the Latin studentem, present participle of studere, to be eager, zealous, or diligent, to study. So as a parent, the key is to point out the right things, the right signposts, so the students will be eager and diligent in learning. If you're a student, then you want to find a selfish reason to be interested in math. Do you feel great when you get high scores and beat everybody else? Does the competition drive you? Or do you want to do good at math so you'll have free time after homework? Find out the benefits of completing math homework, even if you don't like math. For instance, I hate doing chores. I'd rather pay somebody to do them. But for chores I have to do, I look in the future, and I say to myself, if I finish the dishes and sweep the floors, I'll have a few hours to do only what I want to do and nothing else. This becomes a driving force for me to conquer chores so I can do what I want to do. This extends to math class as well. The two most important words teachers and parents should be asking themselves are, so what? In fact, before teachers prepare their lesson plan or parents sit down with their kids to talk about education, Each concept should be attached to a so what, because this forces them to grasp the deep structure of things. And it's way down in the deep structure of things where you'll find the right ideals to get the student excited about learning. Let's look at the deep structure. For a high school student, they go to school. Why? For most, it's to get a college degree. Why do they want a college degree? To get a good paying career. Why do they want a good paying career? Well, for some, it's to raise a family and live in a nice area. For others, they want a sense of purpose. So math class acts like a gateway to the design of your child's future. The excitement comes from the application of the knowledge as well as the revelation of the knowledge. For instance, show a group of kids that math equations can explain part of the universe. Maybe 1 to 2 kids get excited. But tell those same kids that math is used in Xbox video games, the construction of giant skyscrapers, and self-driving cars, and now you've got an entire room of kids at full attention, hanging on your every word. You could hear a pin drop from the silence. Why? Because of the so what principle. Rephrased differently, it's the WIIFM. WIIFM stands for What's in it for me, and it is everybody's favorite radio station. For the next mental model, I want to give you some survey results. In a survey of U.S. teachers, 67% reported that math anxiety was a challenge for their students. 1 in 4 students blame math anxiety for their math performance. In a study funded by the National Science Foundation, they found students experience a visceral response just by being confronted with numbers and figures, also known as math trauma. Math anxiety is now a diagnosable condition. It doesn't stop there. In an international exam given to teenagers, the USA ranked 31st in math literacy out of 79 countries and economies. Overall, the USA ranks 30th in the world in math, according to the National Center for Education Statistics. And it gets worse. Being at such a disadvantage makes it extremely difficult for American students to compete globally, whether it's an international exam, in colleges, or careers that value sophisticated thinking and data science. In short, we have become a laughingstock on the international stage for education, and math anxiety has taken center stage. So how do we fix this problem? Confidence building is great, so is preparation, but we need to handle the mental health side of the issue. First, I like to detect when stress and anxiety start to rush in. Anxiety announces itself through various conditions. Here are a few telltale signs. 1. You clamp or clench your jaw down. 2. You breathe high up on your chest instead of deep in your belly. The breaths are quick and clipped. 3. You have foveal vision, locked and targeted on one spot, versus peripheral vision where you see the full environment in front and on the sides. 4. You have internal jitters. Once you identify the telltale signs, the next step requires alleviation of the anxiety. I think a 15-minute meditation for every parent and student is required. Also, switch to deep breathing, where you monitor each breath. 6 seconds in, hold it for 2 seconds, and 6 seconds out. These tips help you alleviate anxiety attacks. I encourage you to use the breathing tips right before homework assignments, quizzes, and exams, and then use them after as well. Let's talk about another anxiety tip which has changed my life. I call this respond versus react. Suppose somebody comes up to you and says something which sets you off. Maybe it was a political comment. Maybe it was a snide remark. While your first reaction may be to defend yourself or respond with your opinion, I urge you to reconsider. By letting other people's opinions or behaviors trigger a reaction in you, by definition, you are letting them control you. Instead, pause, take a breath, and respond versus react. Remember, you have control over 3 things: your thoughts, your feelings, and your responses. The rest of the world is out of your control. So when you react on a hair trigger, your life resembles a puppet with strings, where one wrong remark lets them pull and manipulate your strings. By responding versus reacting, you gain control back in your life. Your heart, blood pressure, and well-being will thank you. In 2019, the winner of the Kentucky Derby took home an estimated $1.86 million, while second place got $600,000. Third place takes home $300,000, and fourth place gets $150,000, and fifth place collects $90,000. Notice, the prizes are not linear. The winning horse gets 3 times more than second place, 6 times more than third place, 12 times more than fourth place, and 20 times more than fifth place. What does this mean for you? The slight edge. Even if the winning horse only won by a nose, they still get the $1.86 million, which is the lion's share of the prize money. Our society in many races, contests, and skills is shifting towards winner take all, or most. So any slight edge you can get anywhere, in any way, can be life-changing. Book sales, movie earnings, prize winnings, sports, etc. No matter what you do, seek out ways to find slight edge advantages, or get slightly better over time. Play your cards right, and the compound effect gained will be astronomical. The slight edge is about doing simple things consistently over time. When you do this, you will see the following math formula dominate your life. Consistently repeated daily actions plus time equals unconquerable results. For college, a score of a few points higher on ACT and SAT can mean the difference of thousands of dollars in financial aid. It can also mean the difference between acceptance and rejection at prestigious universities. The College Solution reported how Indiana University offers a merit scholarship. A single point on the ACT can be the difference between qualifying for $11,000 versus $5,000 in financial aid. But the slight edge goes beyond college. Suppose you use the slight edge to get 5 to 10% better over time at math. This carries over to the ACT exams. With this gain, you get accepted to a better university, and you get an extra $15,000 in financial aid. Now, suppose it takes you 10 years to pay off your student loans, and your student loan interest rate is 5% per year. If you had to borrow an extra $15,000 and waited 10 years to pay it off, you would have paid an extra $24,433.42 in student loans. And the calculation goes like this: $15,000 times 1.05 raised to the 10th equals $24,433.42. But let's take the slight edge further. Suppose the extra 5 to 10% you scored on your ACT exam was enough to get you accepted at a better university with a better job placement program and stronger college network. Suppose this network was responsible for placing you in a job after college which pays $10,000 more in base salary per year. And suppose you get an average 3% raise each year. For review, and you work there for 10 years, you will earn an extra $13,439.16. And that's found by taking 10,000 times 1.03 to the 10th. This is a hypothetical example, but you could see the power of getting slightly better over time. The opportunities and wealth open up like floodgates for those who score higher and do better. And sometimes, Scoring higher, like horse racing, is a simple adjustment in your strategy. Next, I want to talk about something called loss aversion. Loss aversion is a cognitive bias which describes why the pain of losing is psychologically twice as powerful as the pleasure of gaining. We could sell the loss felt from money or any other valuable object can feel worse than gaining that same thing. Simply put, it's better not to lose $20 than to find $20. Now let's apply this to math. Suppose we have a student who procrastinates, and we want to get them to do homework. We could sell all the benefits of good grades and getting into college, but this approach only works for certain people. If we know, for example, that the student is self-conscious, we could use loss aversion for the motivation. If we show the student how not knowing the answer in class tomorrow could be awkward, they may be motivated to learn the homework, only to avoid embarrassment the next day. In this case, the right thing gets done for the wrong reasons. The best test takers and math students I know use loss aversion, as well as positive factors, to drive them forward in math. One of my favorite quotes is, "You have to hate losing more than you want to win." This is loss aversion summed up beautifully. But only use loss aversion if positive aspects of gain fail to motivate the student. Here are some sample example reframes for loss aversion in math. If you do your homework, you'll get good grades. Instead, you could say if you don't do your homework, you may get held back a grade. If you do well in math, you can get into a good college. Or you could say math students who don't do well lose an average of $15,000 on salary. Do well on the ACT exam and you could get into a good college. Or reframed, for loss aversion, you could say, if you do poorly on the ACT exam, you may have an extra $10,000 in student loans. Again, I want to stress, only use this for people who are away types, which I will describe later in the book. Chapter 5. Decision Making. How would you like to know a simple trick to increase test scores on multiple choice exams? Back in the 1500s, after Michelangelo carved the famed statue of David, people asked him how he did it. He replied, "It's easy. You just chip away the stone that doesn't look like David." Now this level of thinking leads us to our next mental model called the process of elimination. In essence, we cut away what we don't want so we can easily find what we do want. I'll use an example in math to help you picture this. Suppose you have a multiple choice question you don't know the answer to right away. You could start by using the process of elimination. The first question you ask yourself is, can you eliminate any answers? Because even if you have to guess, the more answers you eliminate, the higher the probability you get your guess right. Here is how it works. Consider a multiple choice question with 4 answers. If you guess, you have a 1 out of 4 or 25% chance of getting it right. But if you're able to eliminate one guess you know is wrong, your probability to guess right jumps up to 1 out of 3 or 33%. If you can eliminate 2 choices, your probability to guess shoots up to 1 out of 2 or 50%. Now check out this other example. Suppose you get a multiple choice answer with 5 options. When you're starting out, this means your probability to guess right is 1 out of 5 or 20%. Now, on this question, one of the answers is all of the above. Through the process of elimination, you find out that one of the answers is not correct. If you know for sure one of the answers is incorrect, you know you can also eliminate the all of the above option as well. By doing this, you just boosted the probability of guessing right from 20% to 1 out of 3 or 33%, all from the power of the process of elimination. So the next time you have to guess on a multiple choice problem or find something, why not cut out what you know is wrong so you can get closer to what is right? Next mental model is called Inversion. In the subtitle of the book, I mentioned Warren Buffett's name. He uses many mental models, but him and his partner, Charlie Munger, call our next mental model one of their favorite. When a new skill needs to be learned or a decision needs to be made, most people think about how to do it. What do they need to learn? How do they get good at something? Instead, Inversion seeks to eliminate harm and stupidity. Instead of trying to find out the right way, work backwards and think of all the wrong things you could do. Then, start eliminating those behaviors. As you clear away errors, you gravitate towards the right way. Think about this example. Let's pretend you train somebody to play ping pong for the first time. Knowing how ping pong works, what would be easier for you to teach? Option 1. Hit the ball where the opponent is not. Try to hit the ball within the lines. Make sure you keep your paddle at a perpendicular angle to the ball. Or option 2. Don't hit the net and don't hit the ball off the table. You see how option 2 reads easy for a beginner? If they follow the rules, those 2 rules, the rest of the game falls into place. And by playing this way, they let their opponent make errors by avoiding stupidity. Professional athletes practice inversion during a match. Think about ping pong or tennis. In Charles Ellis's 1975 essay, The Loser's Game, he writes, "The amateur duffer seldom beats his opponent, but he beats himself all the time. The victor in this game of tennis gets a higher score than the opponent, but he gets that higher score because his opponent is losing even more points." End quote. Avoiding stupidity takes less effort than becoming a brilliant person. Charlie Munger sums up Berkshire Hathaway's success using inversion with this quote: "The secret to Berkshire is we are good at ignorance removal. The good news is we have a lot of ignorance left to remove." End quote. Inversion helps you find and remove bad behaviors. Charlie Munger said it best when he quipped, "All I want to know is where I'm going to die, so I'll never go there." End quote. Using inversion, let's think about math homework mistakes. We get less than 8 hours of sleep, so our brains wouldn't function. We'd eat a poor diet, which affects memory and mood, both of which directly affect math scores. We would not do practice tests over and over to learn faster and better. We'd talk to the same people every day instead of making friends with the smartest person in math class to see how they approach math. We'd be lazy and wouldn't write any formulas or important notes down. We wouldn't check our answers, so we'd miss easy problems. The list goes on and on. The key to inversion is find out what you do to hurt your performance and stop doing it. It's easier to eliminate an existing behavior than take on a new one. The beauty of inversion is you focus on what you can control. By eliminating bad behaviors and choices, the right way tends to shine through. The power of inversion comes through addition by subtraction, and nowhere better is it summed up than this quote: "Perfection is achieved not when there is nothing more to add, but when there is nothing left to take away." Anton de Saint-Exupéry. Here's another 2 mental models which go together: Hick's law and decision fatigue. For decision fatigue, I'll turn it over to Mark Zuckerberg for the answer on why he wears the same type of shirt almost every day. Quote, "I really want to clear my life to make it so that I have to make as few decisions as possible about anything except how to best serve this community. There's actually a bunch of psychology theory that even making small decisions around what you wear or what you eat for breakfast or things like that, they kind of make you tired and consume your energy. My view is I'm in this really lucky position where I get to wake up every day and help serve more than 1 billion people. And I feel like I'm not doing my job if I spend any of my energy on things that are silly or frivolous about my life. So that way I can dedicate all of my energy towards just building the best products and services and helping us reach our goal and achieve this mission of helping to connect everyone in the world and giving them the ability to stay connected with the people that they love and care about. So that's what I care about. Even though it sounds silly that that's my reason for wearing a gray t-shirt every day, it is true." End quote. Decision fatigue creeps into many places in our life, including criminal sentencing. One study by researchers at Stanford and Ben Gurion universities found, after analyzing more than 1,100 court decisions, that judges deciding parole cases were 70% more likely to approve parole for prisoners who appeared in the early morning than for those who appear later in the day. This leads to our next mental model related to the paradox of choice, called Hick's law. Hick's law poses that increasing the number of choices will increase decision time. The more choices presented to users, the longer it will take them to reach a decision, but the marginal decision time per extra choice decreases. You see, a few clear options, on the other hand, provide a much better user experience. Think of the sleek and minimalist Apple TV remote or iPhone home circle key. Even my 2-year-old son understood the home button. What does this all have to do with math? Well, first, ask yourself, can you reduce the number of decisions needed each day? A student makes many choices each day, and something as simple as clothing and lunches and homework start times reduce decisions and fight back against decision fatigue. Think about it. If a student doesn't start math homework until nighttime and they've made a bunch of decisions during the day, their brain power gets sapped. And they have limited brain power to use for math homework. Besides decision fatigue, always keep Hick's law in mind. For homework sessions, make the choice easy: time, place, and structure. Make a checklist so if the student forgets, they can read the decisions made and the steps needed. Remember, when you write things down, you can unload them out of your memory. More space means more energy and focus. When we set goals, we measure them by an outcome. What is an outcome? We define an outcome as something you desire that's achievable, appropriate, and measurable. To create an outcome, we need to think in terms of an outcome frame. An outcome frame gives you a set of questions to increase the probability of getting what you want and being satisfied with the result. Instead of addressing why a problem exists, it organizes experience around what is wanted and how is it possible to achieve it. We'll use a mental model called well-formed outcomes to create an outcome frame. Well-formed outcomes force you to outline what your end result is and why. Well-formed outcomes define the context of the outcome and the evidence for fulfillment. To design a well-formed outcome, you use the PECSAW model. PECSAW, which is PECSAW, stands for positive. State a goal in the positive. Say what you want, not what you don't want. How much, how far, where, and what. E is for evidence. You need real proof of goal achievement. How will you know when you have achieved what you want? C is for context. Categories and circumstances. S is for self-achievable. Make sure you own the goal by accountability. A is for advantages. Is it worth it? What is the motivation and benefit of achieving this goal? What do you lose? What's at stake if you don't get this goal? And finally, W, worthwhile. What is important to you about getting this goal? When you create goals, run them through the PECSAW mental model. It forces you to get clear on what you do want, why you want it, and how you'll know you achieved it. Let's take an example outcome using PECSAW. Suppose I want to be rich enough not to work a day job or report to a boss ever again. I determined through simple calculations that $5 million USD will get me to this dream. Let's run this through PECSAW. Positive, I will have a net worth of $5 million. Evidence, my investment accounts and bank accounts will total $5 million. Context, the money must be liquid such that I can earn interest and dividends outside of fees. I must own these accounts with no restrictions. Self-achievable, I am responsible for this goal. And even if I have people helping me to get to $5 million, I must be the oversight and driving force behind their efforts. Advantages, My motivation is to avoid having to work a mundane job, report to a boss, and be subject to layoffs or weak job security. And finally, worthwhile. It's freedom. $5 million with my cost of living, no debt, and inflation rates gets me to total financial freedom. I will never have to work a job, report to a boss, or worry about job hunting ever again. Now, you can use the PECSAW model for math, college financial aid, or the relationships you build, which have to do with your education. Finally, let's talk about another mental model called A/B testing. There is no such thing as failure. Instead, we call it feedback. Failure implies permanence. Feedback implies iteration. Think of our lives as a constant iteration towards improvement. Instead of asking, why is this happening to me? Ask, what is this trying to teach me? If we look at life as a constant iteration, then our goal becomes improvement. Part of the journey towards improvement involves setbacks. But when we call it failure, we set ourselves up for a permanent condition. The best math students treat math and life as one big A/B test. For those of you that don't know, an A/B test involves testing a control, which is an existing setup in your life, versus a variant. In the variant, we change one trait or behavior, keep everything else the same, and test it against the control. If the variant outperforms the control, the variant becomes the new control, and we find another variant to test. Now here's a few examples of what the best math students use and how constant iteration changes your math scores and your life. Control, 7 hours of sleep per night. Variant, 8 hours of sleep per night. Results, 5% increase in math scores when they sleep 8 hours. Control, study alone. Average score of 75 on tests. Variant, study with the smartest kid in class. Average score of 82 on tests. Result, 7-point average increase on tests when studying with the smartest kid in class. All other variables held equal. Control, take practice exams one time. Get an average score of 82. Variant, take practice exams 3 times minimum. Average test score of 90. Result, 8 points higher and 1 letter grade higher with taking practice exams 3 times. Now, what if we stacked all these A/B tests together, one after another? The improvements start to compound, and while the variant may not always win, eventually a variant will win, and if you keep testing variants and more win, the results compound over and over again. This is another secret of the best math students and people who get ahead in life with wealth, networking, and knowledge. They treat life as a constant A/B test, always tinkering to find an edge. And even if you don't have the time or energy to constantly A/B test, if you do 3 or 4 A/B tests, most likely one of the variants will win, giving you higher math scores than you ever would have had without A/B testing. Chapter 6. Systems. What is a system? A process such as an economic growth or maintaining a romantic relationship. A business such as Microsoft or a sports team. A machine such as a toothbrush or a rocket. A state of being such as your health or happiness. Let's talk about another mental model for math which boosts your test scores and evaporates stress. I'll get to the details in a moment, but first, do you have goals in life? Do you know this may be hurting your performance? How, you ask? Well, here's how. Goals. Goals focus on outputs like getting a 4.0 GPA or running a mile in 6 minutes or making 10 new friends a year. The problem is, goals are output-based and outputs are driven by inputs. Goals focus on the big picture and systems focus on the details, and it's in the details where the magic happens. While goals give you a target to shoot at, they aren't always in your control. Inputs, on the other hand, you can control. Remember, winners and losers have the same goal, but one achieves it and one does not. So ask yourself, what is the difference? And the answer is systems. If you look at life as a system, you have inputs and outputs. The inputs are the behaviors and mindsets and skills you have, or you build the goals, which are the outputs. So how do we optimize our life as a system? We use a mental model called systems versus goals. Suppose we have a goal of getting an 80 or higher on a quiz. We don't know what questions the teacher will give in the quiz, but we do know the quiz will cover 5 concepts. We also know each concept contains 2 components. Therefore, we need to focus on 5 times 2 equals 10 components for our quiz. Besides skills, our system also depends on things like memory and brain power. So how do we optimize memory and brain power? These parts of the system also have components. The components for these include sleep, diet, and repeated practice of the components of the quiz. So what you do is ask yourself, what is your ideal amount of sleep? Do you sleep well on your bed, or do you need a new mattress to optimize your sleep for memory improvement? Ask yourself what vitamins and minerals support a strong memory. And finally, we address memory of the 10 components. How do we improve your memory? Repetition through practice. We'd improve this part of the system by taking practice quizzes over and over and over. When you work on the system, you develop good habits. Good habits done long enough turn into permanent behaviors, and they start to become automatic. You see, it's nice to have goals, but it's even nicer to work on the pieces that contribute to your goals. Things you can control, improve the system, improve the end result. The next mental model we'll discuss has built more leaders and wealth and success than I can count. Let's talk about feedback loops, specifically enhancing positive feedback loops and eliminating negative feedback loops. A feedback loop is a part of any system which the output of the system affects or feeds back into the input of the system. Think about a thermostat. If we have a setting at 72 degrees and the room gets warmer, the air conditioner kicks on to regulate and decrease the temperature. Now that we know about feedback loops, let's talk about how to power up the positive feedback loops and silence or eliminate negative feedback loops. First, let's start with the negative. Consider a student who has a poor opinion of their math skills. They constantly bombard themselves with negative self-talk like, "I'm bad at math," or "I don't understand math." Over time, they seek out feedback to confirm their beliefs. When they get a homework problem wrong, they echo these feelings, which sends them down a depressing spiral, making them get more problems wrong. It becomes a self-fulfilling prophecy. On the other side of the coin, we have positive feedback loops. My favorite is compound interest. Interest earned contributes to more interest, which earns more interest. And we can use this principle for math class. Suppose we change one behavior which gets a student interested in math more. After adopting this behavior, their anxiety evaporates, they get more confidence, and they start working at math class more. More work means better grades, which leads to more confidence, and the process repeats. Here is a little secret. The top test takers, math students, and people at the tops of industries all find ways to exploit positive feedback loops. For math class, you may find it with changes in diet, sleep, peer groups, and even tutors. One small change may be the lead domino which starts the process towards a runaway positive feedback loop. Next, I want to talk about change, specifically the 2 types of changes you can make with any system. As we discussed before, systems are processes with inputs and outputs. We want to work on the system rather than goals. Now here's an example in the real world. Consider how many people work for years to get a 15% raise when they could quickly switch to a new job that pays 25% better. Suppose this person aims higher and moves out of a job based on a boss to entrepreneurship with no cap on earnings or passive income. It brings to mind this quote: "When you view the world as a series of outputs, you form opinions. But when you view the world as a series of systems, you form strategies." Channing Allen. For our next mental model, we call it Level 1 and Level 2 changes, and here is how it works. A Level 1 change is a change within a system. You change the cog within a system. But a Level 2 change is changing the system or blowing it up entirely. Sometimes Level 1 changes get the job done and make positive change. But sometimes what you need is a new system or a paradigm shift. Consider a student who's been struggling with math for a long time. We could ask the teacher for help. We could spend extra time on homework. Those are Level 1 changes within the system. A Level 2 change might be revamping the method of learning or hiring a tutor with a fresh perspective. Or, as I said earlier, switching the student's teacher. Another Level 2 change I love comes from learning sources. Why limit yourself to schools and textbooks when sites like YouTube put you a click away from the smartest people all over the world? While you may never meet these people in person, you can get instant education from experts with the click of a button. If you're tinkering in a system and nothing is working, consider exiting the system or choosing a completely new system. Sometimes this is just what the math doctor ordered. Now, to close out this chapter, what I'm about to reveal to you is 14 years of work which built my math tutoring website to get 7.2 million parents and students in a year and have them run over 100 million calculations. We have no employees, and parents and students can get instant help without ever leaving their house. I will never meet 99.9% of the visitors who hit our site, but I can change their lives. And I do this with one mental model: algorithms. Think of algorithms as a fancy word for a recipe or a set of repeatable steps. Take a pasta dinner, for example. Step 1, you boil half a large pot of water. Step 2, when the water is boiling, throw in the box of pasta and cook for 12 minutes. Step 3, when 12 minutes is up, strain the pasta. Step 4, add 2 tablespoons of butter and a pinch of salt into the pasta and mix. No matter what day of the week or what time I eat, I can follow these steps repeatedly. This is how I built my math site to over 7.2 million visitors. And I tell you this because you as a parent or you as a student can use algorithms to conquer math. The best math students and exam takers I know have a process. First, they identify the type of problem to solve. Second, they go back to their memory bank and have a list of steps to solve it. They follow the steps and find the answer. Consider the basic math problem of multiplying 2 numbers. If both numbers are positive, the result is positive. If one number is positive and one number is negative, the result is negative. If both numbers are negative, the result is positive. Once you recognize the problem is multiplying 2 numbers, all you have to do is figure out which of the 3 scenarios above you're dealing with. Then you follow those steps and you get an answer. The same goes for more complicated things like 2-step equations where x is the variable we want to solve for. ax plus b equals c. The answer is always as follows: x equals c minus b all divided by a. I don't care to know anything else. Once I identify this as a 2-step equation with one variable, I know what I need to do immediately. And this leads me to the next great secret of math students and test takers who excel. They think at a higher level. They think in terms of algorithms and steps. Instead of getting bogged down in the problem, figure out what type of problem you are looking at. And once you know the type, the brain can sift through formulas much easier than a bunch of details. I call this metathinking. When I see this problem here, 2x minus 9 equals 31, metathinking says we are doing an algebraic 2-step equation. Notice, I don't care about the numbers yet. I want to know the type of problem we are dealing with. Next, I move down a level and say, we want to identify our variable. In this case, it is x. But the variable may not always be x, so we do meta-thinking and we say our catch-all solution to the two-step equation is this. Step 1. Is this a two-step equation? How do I know this? Step 2. They are in the formula constant times variable plus or minus constant equals constant. Step 3. If this is a two-step equation, then I identify my variable. And step 4, our solution is the variable in step 3 equals the quantity c minus b all over a. If you want to transform math into easy mode, start thinking and learning in algorithms and steps. Chapter 7. Metaphysics. Quote, people become really quite remarkable when they start thinking that they can do things. When they believe in themselves, they have the first secret of success. End quote. Norman Vincent Peale. I am a huge fan of metaphysics, and I think most great math students adopt this outlook as well. Metaphysics is the branch of philosophy that studies the first principles of being, identity, and change, space and time, causality, necessity, and possibility. To simplify, here are the core principles of metaphysics. First, we become what we think about. And second, act as if. For this chapter, I want to talk about a few metaphysics principles you can use to get better grades and make math anxiety evaporate. First is emotional contagion. Step 1. Cut the dead weight and negative influences out of your life. Anything or anybody which doesn't serve you to better your math grades, mood, and outlook should be eliminated from your life. Remember this rule. Happiness and misery love company, so choose sides carefully. We know from mountains of research how your outlook affects your mood and your life. Remember principle 1 above. We become what we think about. If we are surrounded by negativity, doubt, and depression all day, how do you think our lives will turn out? Find positive people and encouraging books and resources to surround you at all times. Next, being, not doing. Let's talk about the next metaphysics principle you can use to increase math scores and decrease math anxiety. I call this being, not doing. The best math students and test takers I know walk into class and wake up each day with the assumption they are the best at what they do. They do this even before they ever got A grades. How can this be? By becoming what we think about. Some call it fake it till you make it, but I think this phrase cheapens the transformation you can make in math class. Metaphysics tells us that we create a thought or an identity about our future selves. We hold it in our heads, and then over time, we become what we think about. Meaning, creation starts in the mind. Instead of seeing is believing, we reverse this principle. Believing is seeing. You must walk, talk, and think like you are the greatest math student in your class. You get the best grades and you figure out all the answers. When you walk through life with this mindset, the universe starts to line up for you and presents the steps and resources needed for you to become what you think about. Instead of doing work to become a better math student, you be a better math student. Do you ever notice when you ask somebody what they do for a living, they answer one of two ways? 1. I work in accounting. 2. I am an accountant. For number 1, the person views themselves as separate from their job role. For number 2, they assume an identity of an accountant. They are being, not doing. The two most powerful words to adopt for your math transformation are I am. The words I am mean an identity. So if you walk through life with the thought, I am a great math student, you take on an identity. And nobody likes to betray an identity. I am means a life change instead of a mask you put on for math class. We see this in superhero movies. When Superman was disguised as Clark Kent, he wore a mask. He was not acting true to himself. He was blending in with what society deemed an average person to be. When he wore his cape, he was being, not doing. Superman is. He does not need to announce himself to the world. He owns the identity. I'm telling you this because assuming an identity of being a great math student who gets excellent grades with no stress starts the transformation to becoming. You'll find evidence of this from the Pygmalion Effect. The Pygmalion Effect says higher expectations lead to an increase in performance. Next, I want to talk about another mental model called the Pollyanna Effect. Here's another mental model which I use with my math students, but can be applied anywhere. What if there was a way to transform math into an enjoyable process with one simple principle? I'll reveal the principle in a moment, but first, let me tell you about some powerful research into the human mind. Back in the 1970s, two researchers named Myelin and Stang found something interesting. They found that people place greater importance on the positive, and we are much more likely to remember pleasant and positive memories. This phenomenon brings us to our next mental model in math, called the Pollyanna principle. The name comes from a 1913 novel called Pollyanna. In the novel, there's a girl named Pollyanna who plays something called the glad game. In every situation, no matter how bad or sad things get, Pollyanna tried to find at least one good thing. She's so good at this game that she ends up getting her whole town to play along, and in the process, she makes a significant positive impact on the people of her town. From this novel, we learn an important secret about shaping our lives. Remember, we all have two drivers in life. We either want to move away from pain or we want to move towards pleasure. The Pollyanna principle goes after the latter, moving towards pleasure. According to the Pollyanna principle, the brain processes information that is pleasing and agreeable in a more precise and exact manner as compared to unpleasant information. So what does this mean? The Pollyanna effect moves you toward the optimistic things you look to in life. It does this by using positive words and positive associations. Consider this. What sounds more exciting, eating a piece of plain broccoli or eating a piece of broccoli covered in chocolate? This is the power of using the Pollyanna principle. We do this through the power of words. You see, each word you ever use in life carries one of three weights. Positive, like the word awesome. Neutral, like the word the, or negative, like the word sucks. So how do we use the Pollyanna principle for math? When referring to your math homework, ask yourself this. Can you reframe your neutral and negative words to positive words? For example, instead of "this homework is impossible," try this. "Homework is an exciting challenge." Instead of "algebra sucks," try this. "Algebra makes me smarter and faster at problem solving." Instead of "math gives me anxiety," try this. "If I can figure out math, I can be great at any subject." As you change your words, you change your reality with the Pollyanna effect. Math becomes a pleasure to figure out and conquer, instead of a stressful burden on your life. All of this comes from the power of words. And this example can be used in any aspect of life, not just math. Frame things and situations in the positive, and watch your outlook and attitude change. Chapter 8. Persuasion. For this mental model, I'm going to use an example I give parents and students who use my math website. Let's talk about another mental model for math called the Hawthorne Effect. Per a University of North Carolina study, when cameras get installed, crime drops. When you have a camera or eyes on you, your behavior changes. In essence, the Hawthorne Effect says people modify an aspect of their behavior and response to the awareness of being observed. How does this help you in math? Well, I'll give you two reasons. First, if you suffer from procrastination, would it help if you had a reminder of how much you procrastinated? And if you had a measure of your procrastination, would you change it? If so, then install the Screen Time app on your phone. The app shows you how much time you spend on the screen. The numbers may shock you. Now try reducing this amount by 5 to 10% per week. And with the newly freed up time, why not use this extra time to do your math homework? Second reason for the Hawthorne Effect and how it will help you with math homework. A camera will help you modify your behavior too, and here is how. If you procrastinate or daydream for math homework, try this trick. Around the time you should be starting math homework, set up your phone to record yourself. And here's the rule. You can only hit stop on the recording when you finish your math homework. When you do this, one of two things will happen. 1, you'll jump right into your homework for fear of being caught procrastinating on camera. And 2, you'll play back the recording and see just how much time you wasted. In summary, install the Screen Time app on your phone and record yourself when it's time to start your math homework. The results you find may just shock you. As I study the best math students and test takers, I find another habit they all have in common. They repeat practice tests, quizzes, and problems. There's a lesson in there for you best stated by Tony Robbins. Quote, repetition is the mother of learning. End quote. When you repeat concepts over and over, your brain starts to pick up patterns. You start to notice things earlier and earlier. Part of this has to do with a part of your brain called the reticular activation system, or RAS for short. The RAS is a net-like formation of nerve cells and their connections lying deep within the brainstem between the brain and the spinal cord. The RAS explains why shortly after learning a new word, you start hearing it everywhere. Or when you find a new car you like, you start seeing it on the road everywhere. Your RAS takes what you focus on and creates a filter for it. I urge you to reread the last sentence because this little bundle of nerves gives you incredible math power via repetition. Earlier I talked about meta-learning, and I talked about the best math students detecting patterns and problems so they could easily leap forward to the solution. When you repeat concepts and quizzes over and over again, your RAS powers up and starts to detect patterns. Use repetition enough, and your brain starts to get a sixth sense about the problems asked and how to solve it. You see things in advance because your brain picks up patterns in math you want and filters out everything else. To use this to your advantage, I urge you to retake practice quizzes and exams in math at least 4 to 5 times. When you do this, you'll miss less and less because concepts repeat, and your RAS will start picking up patterns faster, helping you identify the type of problem. Identifying the type of problem makes finding the solution much easier. Chapter 9. Math. Let's discuss the next mental model for math. It comes from a Japanese principle called Kaizen. Loosely translated, Kaizen means continuous improvement. But here is the magical part. Instead of large improvements, you make small steps each and every day. Take a new skill like sports or math. Suppose you make 1% improvements every day. After 30 days, most people think you'd be 30% better, but that is not the answer. Due to compounding of improvements, after 30 days with a 1% improvement each day, you'd be 34.78% better. After 60 days, you'd be 181.67% better. After 90 days, you'd be 244.86% better. And here's the mind-blowing part. If you continue the 1% improvement every day for a full year, 365 days, you'll end up 3,778.34% better than when you started. You'd be so good at whatever skill you started with, you wouldn't even recognize yourself. Now here's a mind-blowing visual for you about the power of 1% compounding. Suppose in 1776, when America was formed, we deposited $1. We'd make no more deposits. And we just let the $1 compound at 1% per month until the year 2021. In 2021, we'd have over $5 trillion. Now, Let's apply this same 1% principle to math scores. Suppose you have a math quiz or a math test coming up. Before the test, you're able to take practice exams. Let's say on your first try on a practice quiz or test, you score 75, which for most schools is a C grade. Now, we know that repetition is the mother of all learning. So let's take the same practice test or quiz again. But each time we retake the quiz or test, let's assume we get 1% better on our score. By the 7th attempt, we'd improve enough to get a B grade at just over 80%. And after 19 retakes, we transform a C grade into an A grade at just over 90%. Now, consider how life-changing this is for your math career, all from a simple 1% improvement each time. Kaizen helps reduce shocks from big leaps. Consider a woman who is 100 pounds overweight. She wants help. So she goes to her doctor. The doctor does a check and tells her to lose 100 pounds. She asks the doctor how. Doctor tells her to go to the gym every day and alter her diet. Now, what do you think happens next from such a shocking change to the woman's lifestyle? The woman hears the prescription, lifts up her hand, and gives the doctor a middle finger salute. But what if the doctor embraced Kaizen? The woman's action plan would go like this. Day 1, get your gym bag out of the closet. Day 2, get your gym bag out of the closet and put your water bottle inside. Day 3, get your gym bag out of the closet, put your water bottle inside, and add your workout towel as well. These are simple steps which sidestep intimidation. Anybody can follow this, and each day gives the woman a small victory. Do it for enough days, and guess what? By day 10, the woman is in the gym at the front counter registering. By day 15, she's on the treadmill. Kaizen helps you build momentum without the sticker shock of large, quick changes to your lifestyle. Let's talk about the skills pyramid next. I used to know a student who got consistent A's in math. He wasn't a genius. He wasn't even clever. But every year he'd go through the prerequisites needed as a refresher over the summer before his new class started. He'd spend 1 to 2 weeks refreshing his memory from prior courses. Then he'd go back through his old notes. By doing this, he strengthened his pyramid foundation, but he didn't stop there. After looking through the prerequisites, he'd skim through the current class and learn the fundamentals. He started learning lessons ahead of time. He'd have his questions for the teacher or tutor ready in advance. So when classes started, he had a list of what he knew and what he didn't know. He leaped miles ahead of everybody else because he had the fundamentals built. Think of it as running a race where you get a 30-second head start. It's unbeatable. You see, part of leveling up your grades comes from mastering fundamentals. Each fundamental creates another block in the pyramid. Stack up enough blocks, and you will climb higher than you ever thought possible. So the next time you take a class, you do 2 things. 1, you go back over the prerequisites for the class. 2, you start studying the current class early ahead of everybody. Write down your questions so you can ask them in advance. Do this, and you will never miss a problem because you were in the dark. Next, let's talk about the surface area mental model. If omnipresence was a math formula, surface area would be it. The surface area of a 3-dimensional object is the amount of space on the outside of it. Thus, the more surface area you have, the more contact you have with your environment. My first fascination with surface area and the applications for life came from a friend in college. We went to a restaurant to grab some food and my friend ordered a Coke, but he asked the waiter for crushed ice. When the waiter left, I asked him about this. My friend said, crushed ice has more surface area which helps cool the drink faster. The more surface area touching the drink, the more can be cooled. Now, surface area has 2 applications, high and low. Sometimes a high surface area is desirable. Our lungs and intestines have a huge surface area to increase the absorption of oxygen and nutrients. Other times, we want to reduce our exposure, such as limiting our internet exposure to reduce the attack surface. Think of turning the body sideways or ducking to reduce the surface area available to get hit. So the question here is, how can you increase your surface area to be more immersive in math learning, and how can you decrease the surface area of your life, the points of contact in your life, to reduce exposure to things that hurt your math scores? Let's talk about another mental model in math found in many places in life. Math, like life, is a multiplicative system, and nowhere is this better summed up than in this little parable. Two campers were sitting in the tent at night. One camper turns to the other and says, "If a bear attacks us, we're in trouble because bears can run faster than us." The other camper smiles and says, "I'm not worried about a bear attacking." And the first camper says, "Why?" The second camper says, "If a bear attacks, I don't have to be the fastest runner. I only have to be faster than the slowest runner." And the first camper says, "Well, wait, I'm the slowest runner." I love this joke because the first camper realized a harsh truth. All his other skills meant nothing if a bear decided to attack, because his slow speed would have turned him into a bear snack. Now, how does this relate to our mental model? Well, in life, you'll find two types of systems. First, we have an additive system. In an additive system, everything you add helps the system. The other system is called a multiplicative system. In a multiplicative system, everything you add can either hurt or help the system. But some things hurt so bad they destroy the system entirely. Have you ever heard of the theory of the weakest link? It goes like this: you are only as strong as your weakest link. Multiplicative systems have one huge constraint. The constraint is a principle called multiplication by zero, and here is how it works. Consider this math problem. 1,000,000 times 52,679 times 35,243 times 0. Without a calculator, if you picked up on that last number, you could solve that instantly. The answer is 0. Why? Because the first three numbers don't matter. Once we multiply by 0, the other numbers mean nothing. The entire product goes to 0. And this principle happens with math problems as well. Suppose you're working on a math problem which requires three skills you need to know. Variables, you need to know how to divide, and you need to know how to factor. Well, in your current situation, you know variables and dividing quite well, but you have no clue how to factor. This is an example of multiplying by 0. Your weakest link in this case, factoring, cancels out all your other skills for this problem. But there's magic in this principle. When students say, "I'm bad at math," or "I'm bad at algebra," or "I just don't know how to do this problem," this is an exaggeration. Oftentimes, the student doesn't know how to do one piece of the problem, and in order to fix the multiply by 0 issue, the student needs to learn how to factor, and the rest will fall into place. For weakest link problems, you only need to fix the weakest link. After this, try redoing your assignment as you fix your weakest link and improve them. As you improve them, your potential starts to grow and grow, so the next time you struggle with a math problem, list out the skills needed for the problem, and then ask yourself, what skills in this problem don't I know? What skills are holding me back? Focus on learning the multiply by 0 piece and try the problem again. The results may amaze you. Back in the 1800s, an Italian economist named Vilfredo Pareto noticed an interesting phenomenon. 20% of landowners owned 80% of the land. As he studied more, he found the 80-20 principle in other aspects of life. Vilfredo noticed that 80% of his peas came from 20% of the pea pods. And from there, the Pareto principle, or 80-20 rule, was born. The 80-20 rule maintains that 80% of outcomes, or outputs, come from 20% of causes, or inputs. We see this everywhere in nature and life. In the U.S., the top 20% of earners paid roughly to 80 to 90% of federal income taxes in 2000 and 2006. 20% of the medical plan participants account for 80% of the expenses. Microsoft has seen the principle hold true today, as they say that 80% of the tech issues can be solved by fixing 20% of the bugs. In the 80-20 rule, you prioritize the 20% of factors that will produce the best results. Life is not linear, and the top 5% in any industry, including math students and test exam leaders, not only know this, they take advantage of it. The 80-20 rule isn't exact in every field. It can be 85-15, 90-10, 95-5, 99-1. The point here is you will find a lopsided weighting to a small amount of inputs causes to outputs and effects. Check out these insights for math. 20% or so of your behaviors will account for 80% of your errors. Example, not checking your work. 20% of the concepts will be used on 80% of the test or homework. 20% of the things you do during the day affect 80% of your math output, things like sleep, diet, and mindset. As you take practice exams and tests, find out what problems you get wrong. Next, examine the concepts. You'll notice that a small number of things repeat in most, if not all, of the problems you get wrong. Next, let's talk about the substitution principle. The substitution principle gives you another way in math to use mental models to simplify solutions. Here's an example for proofs. If SC equals HR and HR equals AB, then prove SC equals AB. Well, if SC equals HR and HR equals AB, we can substitute AB for HR by substitution, and when we do that, we see that SC equals AB. Substitution goes beyond proofs. It gives you a powerful method to solve equations as well. Check this problem out. The larger of two numbers is 12 more than the smaller number. If the sum of the two numbers is 74, find the two numbers. The first thing we do is declare variables for each number. We'll let L be the larger number. We'll let S be the smaller number. We're given two equations. Equation 1 is L equals S plus 12. Equation 2 is L plus S equals 74. Now, since equation 1 has already been solved for L, we substitute equation 1 into equation 2 for L. And when we do that, we get S plus 12 plus S equals 74. Now, when we do that and solve for S, we get 2S plus 12 equals 74. We group our constants 12 and 74. To do that, we subtract 12 from both sides. We're left with 2S equals 62. And then when we divide each side by 2 to isolate S, we get S equals 31. Now, to solve for L, we substitute in S equals 31 into equation 1. So we get L equals 31 plus 12, and L equals 43. The takeaway here is substitution swaps out one expression for another. Substitution gives you an equal value to use to make things easier to solve. Next, we'll talk about the elimination principle. Do you want to make things easier in math? Simplify and eliminate if possible. The elimination principle helps you clean up and slim down math problems to make them easier to solve. To share the power of this mental model, we looked at the famous statue of David. Back when Michelangelo carved the statue, people in the town asked him how he did it. He replied, "It's easy. You just chip away the stones which aren't David." Let's use Michelangelo's principle to chip away these problems using the elimination principle. Consider this system of equations. Equation 1 is 2x plus 3y equals 10. Equation 2 is 4x plus 5y equals 50. At first glance, this takes some work to solve. But if we multiply equation 1 by negative 2, something special happens. We get negative 4x minus 6y equals negative 20, and 4x plus 5y equals 50. If we add equation 1 and equation 2 together, we eliminate the x terms, and we get negative y equals 30, or y equals negative 30. And then we can use the substitution mental model to substitute y equals negative 30 into equation 2. And when we do that, we get x equal to 50. By using the elimination principle when it's available, it simplifies our solution and cleans things up. By adding or subtracting, we clean up our problem. Next, let's talk about the always principle. I am a fan of absolutes because they use up less brain power and come in handy when you need to solve problems. In math, we have something called the always principle, where certain operations always result in a certain outcome. Here they are. The product of two negative numbers is always a positive, like -2 times -3 equals +6. The product of two positive numbers is always a positive. 2 times 3 equals +6. The product of one negative number and one positive number is always a negative. So things like -2 times 3 equals -6. Negative numbers are always less than positive numbers. Adding 0 to a number always results in the original number. Subtracting 0 from a number always results in the original number. Multiplying by 0, which we talked about before, always results in 0. Dividing by 0 always ends in an undefined result. And finally, even numbers have no remainder when divided by 2. Absolutes in math can also be called another mental model, which we covered earlier, which is first principles. Things at their core which we know to be true and cannot be broken down anymore. For our next mental model, let's talk about something called the order of operations. In math, we deal with operations such as addition, subtraction, multiplication, division, parentheses, and raising numbers to powers, also called exponents. The confusion arises from what order should operations be done when multiple operations exist. When you're faced with a combination of operations, math uses a system called PEDMAS. PEDMAS has a nice way to remember it by using the phrase, "Please excuse my dear Aunt Sally." PEDMAS stands for parentheses, exponents, division, multiplication, addition, subtraction. We use PEDMAS to follow a strict order of operations. Suppose we have the following expression. 4 divided by 1 times the quantity 9 minus 5 plus 6 raised to the second power. Using PEDMAS order of operations, we have parentheses first, which is 9 minus 5 equal to 4. So our new expression is 4 divided by 1 times 4 plus 6 squared. Next, we move to exponents. 6 squared equals 36. So our new expression is 4 divided by 1 times 4 plus 36. Next is division. 4 divided by 1 equals 4, so we have a new expression of 4 times 4 plus 36. Next is multiplication. 4 times 4 is 16, so we have a new expression of 16 plus 36. We don't have subtraction, we've got addition left. 16 plus 36 is 52. For our next mental model in math, let's talk about something called a counterexample. A counterexample is an example that contradicts an idea or theory. So when you form a belief based on something, your first step should be trying to find counterexamples. For math, here are a few examples. A variable is a letter. At first glance, we could say all letters are variables. However, the letters for E, for Euler's constant, and I, for imaginary number of the square root of -1, are reserved for special numbers in math. So we have found two counterexamples which disprove our rules for variables as any letters. Another example comes from prime numbers. Prime numbers are numbers which can only be divided by themselves and 1. Some examples are 3, 5, 11, 13, and 17. What do you notice about each of these? Notice something about them? They are all odd numbers. We could make a knee-jerk reaction and say all prime numbers are odd. However, there is a counterexample. 2 is a prime number but is not odd. When solving problems, watch out for counterexamples to commonly held ideas. Here's the steps to build counterexamples. Step 1, build a list of scenarios. Step 2, create your rule or theory. And step 3, search for any counterexamples which contradict your theory. Finally, let's close out mental models of math chapter with something called the fundamental rule of counting. If there are p ways to do one thing, and Q ways to do another thing, then there are P times Q ways to do both things. This principle can be extended if you have more than 2 items or scenarios. Suppose you have 4 shirts, 3 pants, and 2 hats. How many possible outfits can you make wearing all 3? Using the fundamental rule of counting, we have 4 shirts times 3 pants times 2 hats equals 24 outfits. We can extend this to other scenarios as well. Suppose you have a fair 6-sided die and a standard deck of cards with 52 cards. How many possible combinations can you have if you roll the die once and draw 1 card at random from the deck? Since there are 6 sides to the die and 52 unique cards, we have 6 times 52 equals 312 possible outcomes. Chapter 10. Testing. After studying the best test takers for a few years and absorbing their knowledge, I'm going to reveal the 2 secrets that I learned from expert ACT and SAT test takers. Secret number 1 is a Japanese principle called Kaizen. Now, if you've never heard of Kaizen, loosely translated, it means continuous improvements. So imagine a skill, and it doesn't matter what skill you think of. It could be a sport, it could be a job, it could be a hobby that you want to have to get better at. Now imagine that you want to get 1% better at that skill and that hobby every single day for 30 days. How much better would you be at the end of 30 days? Now most people say, well, Don, we'd be 30% better, but you would be incorrect. The answer is 34.8% better. Now, how does that work? Well, you see the 1% compounds each day. So as you continuously compound the improvements, they build off one another. And that's how you get 34.8% better in 30 days. You see, herein lies the secret of the expert ACT and SAT test takers. Now you may be asking, how does this affect my child? How is Kaizen going to help my child get better grades on test scores and get into college? Well, you see, Kaizen creates another hidden benefit for your child when they prepare for exams like these. And the answer is confidence building. You see, if you were to just take your child and throw them into the exams with little to no help, they would struggle. Their confidence would evaporate and they'd miss out on the benefit of having consistent daily improvements. Kaizen creates manageable bite-sized chunks of learning for your child so their confidence builds and they never get off track. Now I want to reveal secret number 2 of the best SAT and ACT test takers. We call this modeling. When I say modeling, I don't mean taking selfies for Instagram. I mean finding somebody who is excellent at a skill and absorbing and immersing yourself in how they think and what they do. This goes back to my theory on the top 5%. When you see expert test takers, you must understand that they don't think or act like the rest of us. They find ways to identify problems quickly and they recognize patterns. These patterns help them eliminate guesswork, and they can eliminate the time needed to prepare and solve a question. It reminds me of a story that I want to share with you. Back in high school, I sat next to a guy in my algebra class, and every single homework assignment, quiz, and final exam, this guy would beat my scores all the time. He would get 98% scores or higher like clockwork. No matter how hard I tried, no matter how much I studied, no matter how much preparation I put into a quiz or a test or a homework assignment, this guy crushed my scores every time. So finally, I mustered up the courage one day to go and talk to him and ask him how he did it. I said, look, let's sit down and study because I want to know more about how you do what you do. So after 30 minutes of sitting with this guy, who I gave the nickname the Test Machine, I discovered some of his secrets. First, he approached problems different than the rest of us. Most of us are concerned with things like, what formulas do we need to memorize? How do I solve this problem? Am I going to have enough time on the test? The Test Machine ignored all that. He started with, how am I going to recognize what kind of problem this is? And once he recognized what problem this is, he started looking for clues to solve it step by step, like a detective solves a criminal case. And I tell you this story to emphasize my point about the top 5% of any field. They think, move, and act differently. Using modeling, we can step into their shoes and rewire how our brain works. Why sift through textbooks and bang your head against the wall when you could take the elevator straight to the top of excellence? Modeling helps you do this. Next, I want to talk about something called the exam trilogy. Earlier, I mentioned I like to study the best in any field. And during my studies of the best, I found an interesting mental model called the exam trilogy. I'm going to pull back the curtain and reveal yet another secret of expert ACT and SAT test takers. I like to call this secret the ACT and SAT trilogy for short, or the trilogy. Now here's how it works. The trilogy creates a bulletin board of concepts for the ACT or SAT exam. It groups all those concepts into 3 parts. Part 1. Concepts you know and you can answer quickly. Part 2. Concepts you know but you take some time to answer the question. And Part 3. Concepts you don't know or you struggle with. Now here's where this gets fun. The secret of the trilogy lies in how you optimize your child's performance, and I'm going to reveal this optimization in just a minute. But first, I want to talk about how most people prepare for the ACT and SAT exams. Let's assume your child just dives into the exam and they tend to focus on Trilogy Part 3, which is concepts they don't know or they struggle with. What happens is, with each study session focused on the bad part of things, it tends to drag down the other 2 parts of the trilogy. So while they're focusing on everything that they don't know or they struggle with, it starts to affect their confidence. Now let's contrast this approach with how the ACT and SAT experts use the trilogy. What they do is build an inventory of the 3 parts of the trilogy. They'll take 1 or 2 weeks to prepare, and they will take quizzes and sample tests at the end of the 1 to 2 weeks of their first study session. After the first round of quizzes, they will group all the concepts into the 3 parts of the trilogy. Once again, the trilogy is grouped as follows. Part 1. Concepts you know and you can answer quickly. Part 2. Concepts you know, but you take some time to answer the question. And Part 3, concepts you don't know or you struggle with. Now, once they get all those concepts after their first study sequence of 1 to 2 weeks, they're going to take the following steps. Now, buckle your seatbelt because I'm about to reveal a big secret of the ACT and SAT experts. When these experts finish their 1 to 2 week initial preparation, they will start a new 1 to 2 week session with 2 simple goals in mind. They want to move more concepts from Trilogy Part 2, which is concepts they know but they take a little time with, into Trilogy Part 1, which is concepts they know and can answer quickly. Because they already know these concepts, their next goal focuses on increasing their speed, which helps them on the exams. Goal number 2 of the next round of their study sessions takes as many concepts as they can in Trilogy Part 3, which are concepts they struggle with or don't know, and move it into Trilogy Part 2, which are concepts they know but they take some time to answer. If you notice, they are not making the big leap from Trilogy Part 3 into Trilogy Part 1. This behavior happens because they adopt the principles of Kaizen, which we talked about earlier. Kaizen helps them build confidence because they're making small, continuous improvements all the time. If they have a good study session and they make more improvements, they build their confidence. In the next 2 weeks, they repeat these steps over and over again, so they're consistently moving more concepts out of a trilogy to a new and higher trilogy. After a few rounds of repeating this process, their confidence builds and their speed gets faster and their study sessions accelerate. And what happens is they hit the Jetstream effect. Now, if you aren't familiar with the Jetstream effect, let me tell it to you now. Above the earth, there is a stream of air that blows, and when airplanes fly with the jet stream behind them, the planes go faster with less effort. But here's where the fun starts. The jet stream concept applies to the expert method of preparing for the ACT and SAT exams. After a few study sessions of consistently moving items from Trilogy 2 to 1 and Trilogy 3 to 2, after repeating this process, they start to accelerate their mastery. It takes less effort because they get faster and they build confidence. It works much like the planes with the jet stream at their back. I'm going to reveal yet one more secret of ACT and SAT expert test takers. I like to call this secret Myelin magic. What is Myelin? Daniel Coyle wrote a groundbreaking book called The Talent Code, and inside this book he talks about how you could take any skill and turn it into mastery. And by the way, if you haven't read this book, I urge you to drop what you're doing and go pick up a copy because it will change your life as a student or parent of a student. Now, inside the book, Coyle talks about a concept called repeated practice. Repeated practice gives you constant feedback, which helps take a skill and turn it into mastery. But the key to this process comes from deliberate practice. The movements must be perfect or as close to perfect as possible. You want to avoid weak practice where the moves in practice don't mimic the moves in the real world. How does it work? Think about a guitar player starting off and they play the same 3 or 4 notes over and over again, or a tennis player starting off hitting a backhand shot 5,000 times in a row. Now what happens while the guitar player plays the notes a few hundred times? They stumble, they fall, and eventually they get a little better. For the next 100 notes, they get a little better. They fail again, but they get a little better. And the same goes with the tennis player. After the first few hundred shots, they get just a little bit better and just a little bit better. And even though they're failing, they're learning. And as I said earlier, the key to this process comes from deliberate practice. Bruce Lee said it best, "I fear not the man who has practiced 10,000 kicks once, but I fear the man who has practiced one kick 10,000 times." While the guitar player and tennis player repeat the steps over and over, something incredible happens behind the scenes. The body, via the nervous system, builds a white sheath around the nerve fibers called myelin. Myelin acts like an insulation to cover the electrical impulses that flow through your body when you're performing tasks or skills. These electrical impulses fire when your brain makes a decision to make a movement, like strum a guitar, hit a tennis ball, or throw a punch. As you practice more and more, and fail more and more, and learn a little bit more, and repeat the process, myelin starts to grow thicker and stronger. Now what happens as myelin grows thicker and stronger? It helps the electrical impulses move between your nerves faster, which takes you from simply learning a skill into becoming a master. Thicker myelin sheaths explain why you see so many world-class Brazilian soccer players. You see, part of the Brazilian soccer routine for practice is playing a game called futsal. Futsal works just like soccer, however it's played on a smaller court. Because of this smaller court, the players get 6 times more touches on the ball than they do in a regular soccer game on a full-size field. Now, what does this do for these players? Well, with 6 more times touches of the ball, they make more decisions and they fail more. They learn more about how to dribble through players, how to pass, and how to make better decisions. Because the action is moving faster and they get more touches and more opportunities. When Brazilian players play futsal over and over again, their myelin continuously grows thicker and stronger. So when they step out on a regular soccer field, their myelin has thickened and the decisions they make go faster. All the awkwardness and learning curve has been conquered. They've taken a skill and they turned it into expertise. They've turned it into mastery. At my company, we have a program called the ACT and SAT Mastery Toolkit. Inside the ACT and SAT Mastery Toolkit, we set up a 3-part plan for your child to build expertise by building myelin, and here is how it works. For step 1, we take a broad concept and introduce it to your child on the ACT or SAT exam. On step 2, we take the broad concept and we get more detailed. We introduce parts of the broad concept for deeper learning. For step 3, we're going to quiz your child on the small chunk of learning that they just looked at. Now here's how their myelin grows and their scores increase. They go through phases in the ACT and SAT checklist, so after your child takes the first quiz, they get a score. For the next round of studying, they're going to be reintroduced to the concept, learn the details of the concept, and take the quiz again. As they repeat this process, the myelin grows thicker and stronger, and your child gets better scores taking them from a skill into mastery. You see, myelin growth through repeated focused practice explains how the best test takers in the world get their scores. They're consistently building their skill set because they're building their myelin. For our next secret of calculation, I'd like you to look around your home, particularly where you as a student or you as a parent let your child study. Never in recorded history have we had more distractions than we have now. Phones, computers, blinking alerts and lights, the list goes on. And all of it wreaks havoc on study time. First things first, the best test takers and math students I know have a dedicated space for math work. Inside this space, all of them share one feature: quiet. If you dig deep enough, you'll find mountains of data showing the negative effects on excess noise. When you sleep, if you live near highways or airports, your eardrums are vibrating even while you are sleeping. It affects your sleep, recovery, and overall health. The same principle works when you are awake. Quiet rooms help boost creativity and focus. Case in point, I read about a multimillionaire who was coaxed out of retirement to come up with ideas. When he signed his employment contract, he had one request: a soundproof room where nobody bothered him. His only job during the day was sitting in a soundproof room and generating ideas. This was his superpower, and his workspace request demanded that the room be silent and nobody bother him. There's a lesson in there. Silence gives space to the room in your head to operate. To quiet the room, I recommend buying some cheap foam noise reduction panels. You don't have to go full soundproof. However, the more quiet you can make the room, the better. Simply installing these panels makes an instant, relaxing change to any room in your home. Second, remove distraction from the study room. Get rid of phone and computers unless you need the computer for homework. And if you do, download apps to block social media during these times. For our last environment fix, let's talk about symbolism. One of the best exam takers I know put up mock report cards with his name and A+ grades on them around the house. When he went to the bathroom, when he went to the kitchen, and when he went to sleep, he saw those report cards. He even put a digital copy on his phone. So when he saw his lock screen 50 or more times a day, he saw the report card. What do you think repeated exposure to positive expectation of grades does to your brain over time? You rewire your brain for success. If all you see all day is messages showing how smart you can be, your mind transforms the illusion into reality. I saved this mental model for last because it represents the powerful end result to the mental models you've read about. Warren Buffett's partner, Charlie Munger, coined the term Lollapalooza Effect. It means mental models acting in compound with each other at the same time in the same direction. As you use more and more mental models to your advantage, the Lollapalooza Effect kicks in. Compound gains of wealth, speed, and mindset start to build on each other, creating a positive feedback loop. Check out this example. Math students want to improve their grades by treating math class as a system, such as I'll work on the inputs to influence the outputs. Consistency, such as I started a journey to improve my life and math is part of my life. Commitment tendency, such as I am already improving my math performance through mental models, so I must continue. And social proof. Good grades get me more opportunities like attention, scholarships, and higher paying jobs. As I close out this book with our last mental model, I want you to think about the mental models you read about which could help you. Which of them interest you? Now think about all of them working together in tandem towards higher grades in less time without crippling math anxiety. Feels good, doesn't it? Once you use these mental models over and over again, you will discover the Lollapalooza effect in your math class and in your life. Like attracts like, and improvements compound on each other. So pick out and write down the mental models which resonated with you. Then start applying them and watch your math grades and your life transform. Conclusion. Congratulations, you did it. You made it through the book of mental models. Take a few days to think about which mental models resonated with you. Also take time to see which mental models could be added to your life easily. Even if you only see value in a few mental models, apply them for a few weeks and watch how your math scores change. Now, if you'd like to continue the discussion or learn more, check out these various websites. www.mathcelebrity.com. That's mathcelebrity.com, the fastest math tutor on the planet. LinkedIn. My LinkedIn is linkedin.com/in/DONSEVCIK. And on Instagram, my handle is mathcelebrity. If you're interested in joining my math mastermind, where you have private access to my personal cell phone number and Facebook group when you need math help, call 1-800-234-2933 and mention the Math Mastermind. Again, thank you for reading, and here's to you using mental models to level up your life.